Hi, Nitin. I've made you the host, so you can start whenever you're ready.
Okay.
Thank you.
Okay. They were supposed to have a class on chemistry. We are revising chemistry today. Okay, we'll start off with the questions. We'll look onto the theories through the questions. Okay. Fine. So the first question says this. First question is this. So first, go through the solution for this. Okay, so they're telling you to find out what delta H of formation, standard delta, standard heat of formation. Okay. What is, so I have, so okay, delta FH they have given for CO2, CO, H2O as this three values. And they're telling you to find out standard enthalpy change for the reaction. Now, how to find out standard enthalpy change of the reaction? The formula of finding out enthalpy change of the reaction will be basically what? Summation of all the delta heat formation for products minus all the delta heat of formation for reactants or reactants. So what all are reactants? So this is the enthalpy change for the reaction. This is what is the reaction given to you. This is what is reactant, and this is what is product. Okay, so if I'm trying to write it for the reactant, so basically what is reactant? I have for this for CO2 and H2 is reactant, and this is product. For CO, what is the value? For CO, I have minus 110. So CO is minus 110.5. Then other product is H2O. For H2O, it is minus 241.8. Minus and plus becomes minus. Then for reactant side, we have what? We have for CO2, for H2, obviously it will become 0. So for CO2, it is minus 393.5. So if you are solving this will become what? This basically gives you the answer as, this is how much? 110, 240, so 250, 251, 251.8, so 252.3 minus, okay, so this is this is minus 252.8 and plus 393.5, right? It is 252, correct? 352. So this will give you answer something as 41.2. So 41.2 is the answer. Okay, right? So this is how we calculate the delta HF. This is how it is calculated. So the first question is this only, where we have to find out delta standard enthalpy change for the reaction, where it will be product minus reactant. Product is minus 110.5 minus 241.8. If I'm trying to find out answer, it comes as 41.2. Okay. Next question. Yeah. have two questions here. One is the first one 2, and the second question starts from here, the molar heat capacity. This is the first question of 2 years, question number 2, and then this is question number 3. So for question number 2, if I want to write, they have given what is standard enthalpies of combustion of C6H6 and graphite C and H2 are respectively this. Now, if I'm talking about combustion, so combustion is basically, I'll write the combustion process for C6H6. It will be C6H6. Then we'll have O2 because it's combustion. Then it will form CO2 and H2. If you are balancing this, this will become how much? This will become 15 upon 2 and 6 and 3H2. Okay. Anything which is in the form of C6, CX and HY, we can write it as YX plus Y by 4 O2, and we can write it as XCO2 plus Y by 2 H2. This is, you can write any reaction which is in the form of this. This is given to you. For this stuff, the enthalpy of combustion is this much. The second reaction will be, okay, so combustion of graphite, I have C plus O2, which will form CO2. No need of balancing anything here. So this will be this much, and H2. You write it as H2, then you balance it to 2H2, or you just write it as H2 plus half O2, which leads to the formation of water. So this is what are the 3 things. For this in all cases, I have delta H here is how much? Here it is minus 3270. In this case, it is minus 394. And in this case, it is minus 286, which is given the question. What they're asking is find the standard enthalpy of formation of C6H6. I need to find out in standard enthalpy. So the formula for the standard enthalpy of formation of C6H6 is basically C6 plus 3H2. This will give me what? This will give me C6H6. For this, I have to find out delta H. Now, so for this, I have to find out delta H, and I have given this values. Okay. Now, see what I have to get. I am supposed to get C6, and I'm supposed to get 3H2. This is what is my 3 conditions here. So because I want C6, so I'll do what? I'll multiply this equation by 6. I want H2, 3. Both are supposed to be on the reactant side itself, so I don't have to do any negative sign. So because I'm multiplying this by 6, this also is supposed to get multiplied to 6. This also is supposed to get multiplied to 3. If I'm doing that, so what I'm getting now, you can see that this C6H6 is on this side. This is supposed to go on that side. So what I have to do, this is supposed to go on that side. So what I'll do is, because this is supposed to go on this side, this will become positive that time. We'll see that next. First, we'll write this thing. So if I'm trying to find out the equation for this thing, so what it will be, basically what I'll get here is, it will be C6C plus 6O2 for this one. All the reactant side I'm writing first. For equation number this 2. So I have 3H2 plus 3 by 2 O2, which gives me 6CO2 plus 3H2. This is what I have. So you can see that now in this equation, this is total what? This is 15 O2, and this, if you add 6 O2 and 3 by 2 O2, it will become how much? It will become 15 O2. So only thing is what? I can't cancel them. Now, if I can't cancel them if they're on the same side. if I reverse the direction, this comes on this side and this goes on this side. So we can cancel this thing. So what I'll do is this equation, I'll multiply it with, I'll bring this on this side and this thing on this side. Doing though, this negative will become in terms of positive. So after that, we'll be only left out with C6. And so first, if I'm doing this thing, the addition of all this will give me a number as 6 times 394. This will become how much? This will become 2364. 2364 and negative 64. 23. And in this case, it will become 3618. So I'll get 3. So basically, I'll get it as 858. So if I add all both this, I'll get negative 3222. This is what is the for this two equation. Okay, so now if I'm trying to find out, because this will this and this will cancel your this number. Okay, and this I need what I have 602 and 3s2. This and this will cancel you your this and this. Why I'm doing this? This I multiplied to -1 and this becomes plus 3271. The reactant becomes product. Product becomes reactant. So finally, if I have to find out delta H for this reaction, it will become how much? Delta H for this reaction will become, it will basically become 322 and negative of this, so minus minus plus, this becomes minus minus plus, so it becomes 3270. So I get the answer in the form of 48 kilojoules per mole. So 48, so plus 40. Okay. Why I took positive value for this? Because see, I reversed the sign because I want this thing to be on the reactant side. Then only it can get cancelled with this and this. This comes on this side, then only it can get cancelled. If this is on this side, it will get added up to this 6u. Finally, I'm supposed to get this equation by using all these three equations. So now I'm getting all this. This and this gets cancelled. This and this sum is 15 by 202. If this is on this side then, and this I brought on this side, on doing so, this negative will become positive. Okay, this one because to form this, if I'm this much amount of energy is released, negative basically means energy release. To break this again, this amount of energy is supposed to be given. So I need plus 3270 to be given in that, so that I can get this as the final equation. Okay, so this will be how we'll be solving number 2. Number 2. This is how we are solving number 2. Okay. Try number 3. This is basically, this is somewhere we say it as Hess law, but you don't have to remember the name anywhere. You can't say it as Hess law purely, but Hess law is what the concept is being used here. Okay. Why I'm change everything I've shown in the equation, how you're supposed to write the equation, and obviously it will become very long, so you have to be very fast in the calculation. Okay, do number 3. Bottom says answer as C. Answer: molar heat capacity of water at constant pressure at this thing. So Cp is given to you. This is Cp basically. When 1 kilojoule of heat is supplied to 100 gram of water, which is free to expand, increase in temperature. Delta T I have to find out. So delta T will be basically in the form of delta T. I can find it as Q upon MC, number of moles. And this is water. So number of moles of water basically. Fine. So I can write it in the terms of 1000 times 1000 times number of moles. So 100 gram upon mass by molar mass. So 100 upon 18, so 18 comes up, and Cp value is 75. Let's cancel this and this. Okay. 175, so that has to be seen. Other values. We don't have to do calculation further because this becomes 180 upon, we can eliminate the options anyway. It's 2.4. Okay, good. Next. Okay, what it says is it's a 6 mole of an ideal gas which is expanding isothermally and reversibly from a volume of 1 liter to a volume of 1 liter to a volume of 10 liters at 27 degrees Celsius. What is the maximum work done? Okay. So maximum work done in case of isothermal process is given by negative of 2.203 nRT log of 2 upon 3. So minus 2.303. N is 6. R value 8.314. Temperature is 27 degrees Celsius. When converted into Kelvin, it will become 300 degrees Celsius. Log 10.1. Basically, what I get is 2.303 into 6. 6 into 3, I can write it as 18. This 3. Then I have 18.314 into 100 basically. So the value around this will be how much? 8.314 this thing. So 8 to the 16 and 18, 10. Okay. So something around, because it will give me answer in joule. I need to find out answer in kilojoule. So it will come as 34. So this is what will be the answer. This is the formula for isothermal expansion work done when the gas is allowed to expand isothermally. Right. Let's try this. this is printed state, this is delta V, this is delta V. So we can find out using first law, internal energy is equal to set pair E delta V. Using this, we can find out the answer. And this comes something around minus 88 kilojoule. First law. Second law, when we are trying to find out your internal energy in terms of delta H PdV. PdV is with the work done. Okay, next. Now, what is universe? I need to find out internal energy. Internal energy formula. That P minus in case of P delta, instead of that, we can use delta NRT. Delta NRT, where this N is basically the number of moles, change in the number of moles from product minus reactant to try to find out the number of moles in gaseous state. So here you can see the gaseous state is answer is 57.42. It is 1.42. Right answer. Right. So delta H and RT. Here, if I'm trying to find out delta N to be what? Here I have two gases now. On this side I have 1 plus 3 gases. Delta Ng value comes as negative 2. Trying to find out delta H is there as 9 minus 90. Then delta Ng is negative 2. And RT 8.014, so this is basically into delta T is 298 Kelvin is basically 298 Kelvin. Because this is given in kilojoule, to convert this into the same value and divide by 1000. So when I solve this, I'll basically become about 92.38 plus 4.95, which gives us approximately answer as negative 87.43 or 42. So what will be yeah. Okay, so the answer is, he is getting the answer as C. C is right. C is right. Okay. How it will be C? What will be the formula we are using here? W is equal to negative of 2.303 nRT log P1 over P2. And all the values are given to you. And 1 mole is N. R you will use 8.314. No. Gas constant, I have mentioned it as 2. So I'll use R as 2. Okay, because we are getting answer in calorie. So R is this, temperature is 273 Kelvin given, P1 and P2 is given. So 10 and 1. So just substitute everything, you'll get an answer as this. Okay, good. Let's see the next one. Okay, so we have 2 questions here, number 8, number 9. First do 8. Number 8 solve. Okay, so you see this basically asking you heat of formation of SO3. Using 2 equations, I'm supposed to find out SO3. You see here, if you add this 2 equation, this and this gets cancelled, and addition of this and this will give me how much? If I'm adding S, this will be what will be left will be SO2. It's half O2. It gives me SO3 basically, right? 3 O's. Okay, half O2 is there here. Okay, so if I'm trying to see that, so what will happen if I'm add 2 equation? I'm going to add 2 equation. So basically, what I'm going to get here is this will be basically S plus 1 by 2 O2. Okay, so if I'm trying to solve this, Now, if you want to balance it, that's a different scenario. If I'm trying to balance it, anything other things will get disturbed. Okay, I'll not get SO2 will not get cancelled. So because of that, we go with the option of x plus y. Okay. Slide 9. Number 9. Slide number 9. Okay, if I'm trying to solve this question, they have said that at a constant volume, the specific heat of the gas is 0.075. That is, CV is given to you. Its molecular weight is 40. So the gas will be what? Now, what we know is we can find out the value using what is constant value weight. So what I can do is to find out CV, molar heat capacity, that this is constant volume, the specific heat of the gas is this much. I'll try to calculate CV from here. This is given what is, I'm trying to find out CV value. So CV value can be found out what by using what? If you have specific heat at constant volume, this is, if this is, it is not molar heat capacity. CV is basically molar. So that to find out CV, what we'll do is using this, we can find out CV, specific heat at constant volume. And with that, if I multiply the molecular weight, I'll get CV. So 0.075 times 40 will give me the answer for this. Okay, so I took it as, so the value came it as 3. So they haven't, so the value will become 3 calorie over here. Now, again, I can have Mayer equation. Using Mayer's equation, what I know is Cp minus Cv is equal to R. So to find out Cp value, I can do Cv plus R. So R being 2 calorie, and so 3 plus 2, this will become 5. Okay, this will become 5. Now I can find out the gamma. Gamma is ratio of Cp to Cv. Cp is 5, Cv is 3. This basically justifies to be 1.66, which is a value for gamma in case of monoatomic gas, which is in the case of monoatomic gas. So using this, I can find out that it's a monoatomic gas, right? Okay, it's a monoatomic gas. Try to go to the next question. Okay, try. Anyone? Okay, let's see. By whatever the equation of gas equation says what is PV is equal to nRT. PV is equal to nRT. So from this, if you see that if volume and RT is constant, so I can say that the partial pressure, the pressure will be proportional to number of moles. What I can write as N1 is proportional to P1, and I can write N2 is proportional to P2. Right, so I can write this as that N1 upon N2 will be equal to P1 upon P2. N1 upon N2 will be equal to P1 upon P2. That's all. We have partial pressures given. P1, if I'm assuming it to be P1 cyclopropane, so 170 torr over 570 torr. 170 torr over 570 torr, which comes approximately is equal to 0.3. This is what is the thing there in that. After that is solving it. Okay. Next. So York says answer as C, near the ammonia bottle. Okay. See how the answer will be here. Basically, what we know is we can write it as the rate of diffusion. The rate of diffusion is inversely proportional to root over molecular mass. Now, I know that molecular mass of whose is greater, HCl is greater than molecular mass of ammonia. So whose molecular mass is more? Okay. So HCl will get what? It will diffuse slow. So HCl will get diffused slow. So that's why ammonium chloride is first formed. That's why ammonium chloride will be first formed, and it will be nearer to hydrogen chloride bottle. Nearer to hydrogen chloride bottle. Because what will happen, which will get diffused? Because the molecular mass of HCl is there, this will diffuse slowly. Okay. This will get diffused slowly. That's why you will find that ammonium chloride ring first found will be here. Okay. Okay, next. Okay, so they're telling you the time taken for the diffusion for the same volume of a gas specified under identical conditions. Okay, X ml of H2 gas is fused through a hole in the container 5 seconds. Okay, now to the rate of diffusion, if you try with time taken for the rate of diffusion, so ratio will be is written like basically this. So I can write from here as what? That T by M ratio, if I'm trying to find out T root over M ratio, that will come same in which condition. So H2 is basically this. Okay. H2 is 5 seconds, and this is its molecular mass. So for H2, if I'm writing rate of diffusion, it will become 5 root 2. Okay, for others, if I'm trying to find it is 10 seconds for helium. So helium will be how much? 10 seconds upon helium is 4. So root over 4 is 2. Then for our oxygen, it is 20 over root over 32. Now root over 32 will be what? How much? 4 root 2. So 4 root 2 will be basically, so this will become 4 root 2. So 4 root 2 is 4, and so 4 times 5. Okay, yeah, so this and this become same. It is same for this one. Okay, this basic formula is what? Time taken for the fusion upon the root over of the molecular mass is constant value. Based on that, we can write down this. Try the second one, 13th. Okay, this will be again same thing. The rate is proportional to 1 root over, so root over molecular mass. So whose molecular mass will be more, rate of diffusion will be less. You have to write it in which is correct order. So CO2 obviously that, so whose rate will be more, so rate for CO2 will be more. So option D is right. This is what is the formula, rate of diffusion formula, both we have used already. Yeah, answer will be A, because the critical temperature, whose critical temperature will be high, though it will be liquefied easily. That's how it goes. Okay, it's directly proportional relationship. Whose critical temperature will be higher, it will be getting liquefied easily. Okay, so it's number A. Good. You can write the formula also if you want, how this is related. The formula for critical temperature is what? A times A upon 27 RB, where E is the constant which decides about the liquefaction of a gas. So you can see that the critical temperature is directly proportional to A. So whose critical temperature will be high, that will get liquefied easily. So number option A. Good. Next. Yes. Okay. So option 15 option is okay. So single atom. Yeah. They're asking me for the single atom, so I can find out the single atom will be basically what? It will be for single oxygen atom. It will be basically 16 upon Avogadro number, that is 6.02 into 10 is to 23. So this will give you answer as next one, 16. So this kind of questions can be asked. Now, whatever questions I'm doing from yesterday, whatever questions type I took in physics, or whatever question type I'm taking in chemistry, or further whatever I'm going to take, everything I'm doing it keeping Compex in mind. These questions are like this kind of questions are there in this. You can see the time slot there for 30 questions, 60 minutes time slot. So they expect you to be good. And this is physical questions. Physical chemistry will be numerical. And other two where you have inorganic and organic questions, it will be basically memory-based questions. So there you save the time for calculations. So basically 30 seconds on inorganic questions. Okay, fine. So Komal also got the same answers here. So this is what it answers. Okay. Okay, next. Next question. So see, in this kind of question where they're telling you to find out the oxide of an element contains this much of oxygen and vapor density of volatile fluoride is 79, equivalent weight of the element. See now, they're telling you that out of 67, the oxide of an element contains 67.6% of oxygen. Okay, so and so how we try to find out the equivalent weight for this. The oxygen, the mass is 32. In the question, they'll mention you, though this will be 32.33, and the total percentage for this is 67.67, and we try to multiply it with the atomic number of oxygen. So this is how we try to find out questions related to this. This is what is the formula. How it comes on this thing, you don't have to get into that. Oxide of an element contains this much. You have to remember, if they're telling you to, like, say they have given you extra this thing here. If they would have told you chloride over here, So they would have given you the percentage for the chloride. Still, it will be oxygen chloride is very difficult to be formed, right? It will form a non-metal. That's true. So this is what oxychlorides are possible, but that is again in that case also same thing. Whatever the oxygen will be there, O2 is 32.33 mass percentage if they have given, and here what will be multiplied will be your atomic weight of the oxygen. Okay, next question. Empirical formula question, easy. You have to find out what? We have to find out the ratio of atoms. So I have 24 gram, 4 gram, and 32. Instead of wasting a lot of time, what we'll do, we'll just find out the ratios over here only. So it is 24 upon 2 for carbon, 4 upon 1 for hydrogen, and 32 upon 32 only. So this is 32 upon 16, sorry, oxygen. So this is what, so the ratio here will be what, 2 is to, it's 4:2. Now we have to divide everything by the smallest number. So it will be 1:2:1. So this is basically what empirical formula. So I have CH2O. CH2O becomes empirical formula. This is a, don't get into forming tables and all. Just do it directly. You find out the ratio of atoms, the mass by molecular mass, mass by molecular mass, mass by molecular mass. Okay, so this is sorry, atomic mass. So this is all atomic mass we added. We got the answer. Okay. Next. Okay, next question. This is easy. This is molarity formula. Molar concentration of 20 grams of NaOH present in 5 liters of solution. Molarity, how you will find out? Mass, so number of moles of solute. So number of moles of solute will be what? Mass by molecular mass, that is 40 grams. And there, this is basically in 5 liters. So I don't have to change it. If it is in the milliliter, then I have to change it into the liter. So this is all. So this is 1/10. So 1/10 is nothing but 0.1. So 0.1 moles per liter. Molarity formula is what? Molarity formula is number of moles of solute, right? Number of moles of solute. Number of moles of solute upon volume of solution in liter. Upon volume of solution in liters. That's why. So the next one. The normality of solution obtained by mixing 10 ml of N5HCl and 30 ml of N10HCl. The formulas for this kind of situation is number of moles. Sorry, the normality is given as normality in first condition times volume in first condition plus normality of the second solution up then volume of second solution upon sum of the total volume. If I have solution 3, so like that only it will be N3V3. So if I'm doing that, N1 is basically, I have it as 1 by 5. So 1 by 5 into 10 plus 1 by 10 into 30 upon the volume. So volume is 30 and 10, 40. So basically this will be what 5 times 2, 3. So 5 upon 40, or we write it as 1 by 8 or N by 8. This will what will be the normal. If it would have been molarity, still the formula will stay same. For molarity also, we can write it as M1V1 plus M2V2 upon M1V1. Sorry, V1 plus V2. Same thing. We can use the same formula in terms of normality and molarity both as well. Next, yeah. Try to solve. See, okay, I'll solve this. So number of moles, we can find out number of moles, how much is there in 200 mg of CO2. So I'm trying to find out number of moles in CO2. What is given 200 mg? That will be given as what? Whatever mass we have. So mass, because it is milligram, so 1000 into molecular mass. So this will give you the number of moles. this gives me the number of, this gives me the number of moles as what? It's basically 1 by 22. 1 by 22. So something around, if you try to find the value for this, you get the value for this is 4.5 into 10 raised to minus 3 moles. Okay, 1. So this is what is in 200 mg. Now, from that 10 raised to 21 molecules have been removed from that. This is the total number of moles. Sorry. Now to find out number of moles in 10 raised to 21 molecules, how many are this? Because I got moles in this, I'll convert this molecule. Either I could have converted this into terms of molecules or this into terms of moles. If I'm trying to convert 10 raised to 21 in terms of molecule, so it will be 10 raised to 21 upon the Avogadro number, particles by number of, because that is the one more formula for number of moles, particles by the Avogadro number. So if we do this, we get this thing as 1.67 into 10 raised to minus 3 moles. So now how much is left if they're asking? So we can do what is 4.5 minus 1.67 into 10 raised to minus 3 into 10 raised to minus 3. So this will come something around 2.88 into 10 raised to minus 3. So this is what will be your answer. The number of moles formula is basically what? I have three formula: mass by molecular mass. Then one is particles, number of particles upon Avogadro number, and other one is volume of the gas at STP upon 22.4 in liters. So this is the three formulas where the number of moles is. So I'm using two formulas here. One is mass by molecular mass, this one, because mass is supposed to be in gram and molecular mass as well it has to be in gram. And the second formula of number of moles I use is number of particles. So this is this one. So all these three formulas, any of this can be used, either combination of three or combination of two or only one. Any can be used. Right? I hope it is clear. Let's move to the next question. Yeah. Let's see. A molarity of H2SO4 solution which has density this much contains 98% by weight is how much? Okay. So now what they're saying that 100 gram of solution contains basically 98 gram of H2SO4. That's what it means. It's 98 grams. So what I can write here is that this is density. So for the solution, if I'm writing, so volume will be how will be written? Density is equal to mass by volume. So volume will be what? Volume can be written as mass upon density. So what I can write is this much volume of H2SO4, this much volume of H2SO4 contains 98 gram of H2SO4. This much gram, this much, this is what? This is for solution. This much volume of solution contains 98 gram of H2SO4. That is what the first step says. Now, to find out that in thousand why it is how much, because they're asking to find out molarity. Molarity is basically what? Number of moles by volume in liters. But here the things is given in the terms of milliliter. So for milliliter, if I'm trying to write what I write for milliliter, 1 liter is equal to how much milliliter? 1000 milliliter. So for 1000, if I'm trying to find how much it will be, I just divide it by 1000. So what? How I'll write it? Basically, the question will be turning in this form for 98 by 100 for 1000 if I'm trying to find. So 98 times 1000 into 1.98 by 100 into 1.84 into 1000. This many grams. Okay. So we have to find out the answer for this. This much gram. But I have to convert this. So this is what this is. This much gram of H2SO4. This much gram of H2SO4. This is what is mass. In what? This is in 1000 ml. This is in 1000 ml of solution. 1000 ml of solution. Now to convert this into number of moles, so I'll divide it by its mass. It will become 9800 by, which is 1.84 into 1000 upon 98 1, because this is what is mass by molecular mass converts it into number of moles. So this and this gets cancelled. So we'll get the answer something around 18 point, because this and this also gets cancelled. So I get the answer is something around 18.4 mole. This is how we try to calculate the. This is how we'll try to calculate the polarity for this condition. Let's try next question. Yeah, all this. Okay, let's see the answer. The reaction of calcium with water is represented by this reaction. Now, when we are trying to what volume of H2 at STP would be liberated when 8 gram of calcium completely reacts with water. That means it is getting completely over. Now, when I'm talking about this situation, so you can see that this is if I have 1 mole reacting with 2 mole of H2O, 1 mole of this reacting 2 mole of this, it will form what? So what volume of H2? I have to find out what volume of H2 at STP will be formed. So if 1 mole of this reacts with 2 mole of H2, it forms 1 H2. This is what is the complete reaction. So now if I'm trying to find it for calcium, so I can see if I'm writing it for calcium, basically, so it will become how much? If I'm trying to find it, so if I'm going to the stoichiometry of this, what I can see is 40 gram of Ca, because the molecular mass of calcium is 40 gram. 40 gram of Ca forms how much? 2 grams of hydrogen. 2 grams of hydrogen. This is the first condition. I'm getting it from this. 40 gram of Ca forms 2 gram of H2. Now they're telling that 8 gram of calcium, it will form how much of H2. Now, if this much is this, so for 1 gram of calcium, it is how much? For 1 gram of calcium, it will be 2 by 40. So similarly, for 8 gram, from 8 gram of calcium, it will be what? 2 by 40 times 8, which is 8 times 540, and this comes something around. So this will become what? 2 by 5, you write it as 2 by 5, you write 8 times 40, so I have 2 times 5. Now this is what this side got its total, what 8 gram of this much it will form. Now because they're asking you what is the volume, so this is to convert it into the volume. What I'll try to do to convert it into the terms of the volume. So 2 by 5 I got to convert it into terms of volume, because they're giving it in centimeter cube. Because so 1 mole is basically equal to how much? 22.4 liters. So still what I have, this is what this 2 by this 2 by 5 I'm finding. So this 2 by 5 is basically what? It is mass. So 2 by 5 is basically the mass which is formed. This 2 by 5 gram of H2 will be formed. Now this is 2.2 by 5 gram of H2 is formed, but they're asking me what volume. So now I'll first try to convert this into the terms of moles. So number of moles of hydrogen will be what? Mass by molecular mass. So molecular mass of hydrogen is again 2. So I can write it as that I have number of moles is 1 by 5. Now 1 mole of anything, 1 mole of anything at STP, 1 mole of anything at STP is equal to 22.4 liters. 22.4 liters is nothing but 22400 cm3. So because so now 1 mole is this much. So 1.1 by 5 mole will be how much? 1 by 5 will be 1 by 5 times 22400. 22400 cm3. So if I am trying to solve this, it will be something around. So 5 4 are 25. So this one. Okay. So first I found out what is the number. First I found out that for 8 gram how much hydrogen is being formed. I converted that hydrogen into number of moles, and this number of moles, when I write that 1 mole of anything at STP, it contains how much? 22.4 liter of that particular thing, which is equivalent to 22400 cm3. So 1 mole is this much. So 1 by 5 will be how much? I calculated that. So I'm getting this as. Let's see what is the right. Fine. Let's try the next one. Which has the maximum number of molecules? Which have the maximum number of molecules? Simple thing. If you find out number of moles, through that if you're trying to get the number of moles. That's the answer. To find out the number of moles, that many atoms it will basically form. SO2. Okay, so we have to find out which have maximum number of molecules. So what is easiest for me that I'll convert everything into terms of number of moles, and then I can find out number of molecules by multiplying it to the Avogadro number. So if I'm trying to find out the number of moles for the first case, it will be how much? Mass by molecular mass. So 1 mole. Mass by molecular mass. So 4 moles. Mass by molecular mass. So mass is 48, 48. Mass by molecular mass 64, 64. So 1 mole. So if I'm getting this as 1 mole, so how much will be mole multiplied to that Avogadro number will be your number of molecules. So this will be 4 Na. That is 1 Na. This all is Na. So this is very clear from the question that this will have more number of molecules. So 8 gram of H2. How I wrote that thing, I said you the formula for number of moles. One formula is what? Number of particles, which can be what? Number of particles can be molecules, it can be ions, it can be atoms, protons, all that. And upon Avogadro number. Upon Avogadro number. So this is what I found. I multiplied this 2. When I'm multiplying this 2, this gives me number of particles, which in this case is molecules. So I got number of molecules. So that's what, using that I got to know that this much is the number of molecules, this much number of molecules, number of molecules. That's why this is more. This is the right answer. Next one. Okay, 26A. Fine, let's see. You have been doing the questions like this for molarity, that on dilution, when water is being added to, that is basically case of dilution. On dilution, M1 V1 is equal to M2 V2. Similarly, I'll have normality also, which we write as N1 V1 is equal to N1 V1 is equal to N2 V2. Okay, this is in the case of dilution. So N1 V1 is equal to N2 V2. Now I can see the number of moles here. In the case of normality, first is 10. Volume is also 10 ml. And then in second case, the normality given is 0.1. Volume is not given here. So if I'm trying to find volume from here, it will become 1000 ml. But this 1000 ml is what? This 1000 ml is volume of what? This is 10 ml, 10 Newton HNO3. It is mixed to get this much. This much is what you're mixing something from here. You're mixing some amount of water from here. So for 10 ml, you're mixing. So here 10 ml already it was there. So you mixed something. So that time the volume became 1000 ml. How much you missed? 990 ml. Because already it was V1 was what? 10. Then V2 became 1000 ml after dilution. So for 10 ml, it became 1000 ml. So how much increase happened? Increase of 919. This is what will be the answer. Number B. Number B. Your answer for V2 is fine. But you have to find out that what was the volume added to make such volume on dilution. So this is because when you're adding water is basically is the case of dilution only, right? I'm trying to make the water diluted. So we have property where one question which we did was what normality for which one N1 V1 plus N2 V2, N1 V1 N2 V2 upon V1 plus V2. So this was what? This is the final mixture. Normality for the final mixture we find out. And this is what we are trying to find out on dilution. This is what is the formula. So this is two different cases. This is volume at normality of the mixture when these two are mixed. Let's see the next. Next is this. If you know that, if you will be knowing that this is there, this is a situation. If electrons value, you know this is the standard answer. And this also, if you know, according to the cathode ray experiment done by J.J. Thomson, this is E by M ratio. So you will know that using this two only, we have calculated mass of electron as this much, which is a standard value to remember. 9.1 into 10 raised to minus 31 kg. So sometimes you should see that we really need calculation only. Okay. Yeah. So 9.1 into that. Next. Try this. Okay. Let's see. Now, when we are talking about the energy of an electron in first energy cell, this is given by this. I know with the equation that energy of nth orbit, the value is given as 13.6 Z square upon N square. This is there in erg per ATM. This is an erg per ATM. Z square by N square. So I can see from this that En is inversely proportional to N square. And it's directly proportional to Z square. But because for particular atom, it will be Z square will be constant. So we are writing En is inversely proportional to N square. So for what I can write that E1 upon E2 will be basically equal to N2 upon N1 and square of both these things. Now I can use this. I need to find out energy for the second label. So A2 will be basically what? E2 will be basically equal to E1 times N1 square upon N2 square. So E1 and E1 is basically I have negative 21.79 times 10 raised to minus 12 into 1 square upon 2 square. Basically, we are trying to divide this by 4. So 4 times 5, negative answer I'm getting, and 10 raised to minus 12. So this will be the answer. Only this thing, and this all the concepts I'll expect you to remember. This is there in physics as well in the modern physics. This kind of questions you can expect in your exam. All of this, whatever we are doing, is a type of questions which can be expected in your exam. This question session will be purely question session, which will be further. Also, we are having 2 sessions which based on questions. Through the questions, we are looking up to what kind of questions we are going to get, and we are just brushing up the theories as well. Next, yes, de Broglie wavelength, famous, common. Kinetic energy is given. Okay, then try to solve. See, we have been using this formula in physics as well. We have done it. We know that kinetic energy is equal to half mv square. Okay, it's half mv square. So this, if I want to calculate the velocity, velocity will be equal to what? It will be 2 times of kinetic energy under root 2 times of kinetic energy upon m. Now it is an electron, so I can write it as what? 2 times kinetic energy. So 2 times of kinetic energy is 13.6 electron volt. I'll convert 13.6 electron volt into joules. And the mass is again for electron is how much? It's 1.6, sorry, 9.1. Mass for electron is 9.1 into 10 raised to minus 31 kg. Yes, 10 raised to minus 31 kg. Okay. So when we are going to solve this, this answer is something around 2.18 into 10 raised to 6, which in general also according to the boards, we find out the value for Vn, that is V1 or V0 we say. For that also we get this value. Okay, so this is what is velocity we're getting. Now they're telling to find your de Broglie wavelength. So lambda is equal to h by mb. H by mb. H is 6.62 into 10 raised to minus 34 joules per second. Sorry, joules second. And m is again 9.1 into 10 raised to minus 31. Into velocity, we have 2.18 into 10 raised to 6. If you solve all this, you get the value something nearer to 0.3328 nanometer. 0.3328 nanometer. Okay, so this is two formula relation. This is de Broglie wavelength. This is normal kinetic energy formula. So through kinetic energy, we got velocity. From velocity, why I converted into joules? Because you see here values and all is joules, SI units, kg, meter per second. All are SI units. So if you solve this, this will finally give you answer in meter, and then it gives you the nanometer answer. Next, the velocity of an electron in the second cell of hydrogen atom. Answer it right. Same formula, velocity formula. Velocity formula for nth orbit is 2.18 into 10 raised to 6 z times z by nanometer, sorry, z by n meter per second. So this is n value they're telling for second cells to 2, and z is for the hydrogen atoms to 1. So this is quite good. Next. Try question number 35. Question number 35. So if I am knowing the formula, E is equal to hc upon lambda, I can write that, or I can see that I can see that basically here, and from this question I can write that E is inversely proportional to wavelength. So from this, if I want to write, I can say that E1 upon E2, E1 upon E2 is basically equal to lambda 2 upon lambda 1. Lambda 2 and lambda 1. So lambda 2 is given as 6,000. Lambda 1 is given as 3,000. So this will be basically ratio of 2:1. You can see this is direct formula. This is energy of photon. And HNC is constant, Planck's constant, and velocity of light. This is how we try to interrelate, and we can get the answer easily from this. You don't have to substitute anything. Okay. Let's see next. Yeah, which of the following combination of quantum number is not allowed? Answer is D. Okay, let's check. See, when I'm talking about n, first thing what you're supposed to know, n is whatever n value will be there. Based on that, if I'm trying to write L value will go from 0 to n minus 1. Any value in between this is acceptable. M value basically goes from minus L to plus L. Anything in this is acceptable. And the spin quantum number can only be minus half or plus half. Spin of quantum number can only be minus half or plus half. So based on this, if you want to write, based on this, if you see, so 3, your answer 1, 0, so see for 1, this 0 is allowed. But this is, so they're saying that which of the following combination of quantum number is allowed? This cannot be allowed, because if this is L is 0, then this can, the only value it can take is 0. It cannot be more than that. It can be, I said, what, minus L to plus L. So 0 means it will stay as 0. Now further you see here 3. So if it is 3, this can also be not allowed, because it can only be up to what, 2. This can only be up to 2, that is n minus 1. So yo, where are you from? I'm from Ranchi, Jharkhand. Okay. So this is right. So this is 2. So this can be basically, now you see this can be true because this is 2. So this can be 0 because it's taking value in between n minus 1. And for 0, this can also be 0 and minus 1. So this is fine. Here you see this can be 3, this can be 2, this can be 1, this can be 0. So whichever following, this cannot be 0, right? This can only be what? Minus half or plus half. So according to that, which is correct? So only option B is right. Next, which of the following is an isoelectronic species? Which among the following is an isoelectronic species? Isoelectronic species are those species which have same number of electrons. Same number of electrons they have. Syllabus wise, you can go to the step of solution on the YouTube. Everything has been discussed on the first orientation class. Everything is present on that regarding syllabus. You can see number of electron where it can be same. This is, so which case will have it same. So here we can have it same. See 8 and 6, 14. N is 7. This is 8. So 8, 7, 15 plus 1 chance of 14. C is 12. N is 7. So C 7 and 6, 13 and minus 1, 1 increase 14. 12 and 2 minus is 14. So this all is an isoelectronic species. This is what is some questions of on chemistry. I will continue with these questions later on further than on our next second session. For now, this is what we have for today. Okay. So this is it for today's class.